Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. Right, so now you've got this big thing here. This is going to be a bit more interesting. I'm pretty sure I purchased this off someone that actually watches my channel. Pretty sure it's a viewer who's selling something on eBay. He's like work for a company that does resale stuff, it would seem, and they seem to recognise me, so I think they watch my channel. So if it's from you and you watch my channel, then thanks, well done. There we go. Nothing else in the box? No. So as you can see, this is a Agilent E3646A power supply. It does light up and stuff like that apparently, and it does have a fault on one of the outputs. Right, so this is a non-perfect unit, I suppose you could say, because it does have a fault, which is perfect because that's exactly what I want. Right, so this is using Torx bits. So these are the bits I had arrived the other day in Mailbag actually, so very convenient. I believe I've just got to take those off and I can hopefully slide the cover off. I might take the handle off as well. So this removes the rear trim, which then should allow the housing to slide off backwards. So I want to check the voltage setting, that's all. Obviously I need to open it anyway to try and diagnose the fault that's on it. There's evidence of these screws being taken out before this slightly rounded, so it's not his first time being opened. It's not a virgin, certainly not. So there we go. Now so I hear something ratting. I think it's just some retainer bolts or something. Don't think it's anything major. Okay, where's the voltage settings? See that switch there? There's actually two switches right here. So let's see what they say. I think that is 115 volt setting. I think it is. I'll come back in a second. Right, so according to what I could see on these switches here, it's actually set to 115 volts. That is set to 115 volts. If I flick this switch here over to the left, to there, that should now be 230, as marked on the back panel. So it's interesting that it started out 230 and they've never actually remarked the back panel when they've changed the voltage range. That's a really bad thing to do. So if you ever get a bit of gear and you change a voltage setting, and it's like a permanent change for your region, change the markings on the back. You know, if I hadn't double checked that, I could have blown the crap out of this power supply. And I actually just noticed something actually. I'll show you this. I thought it was a bit mean. Now, this is on the casing. It's got a stamp in here saying when it was made. So 27th December 2007. A shift. Good old A shift. Now, that means this is 11 years old, which isn't that bad. You know, it's fairly young really. But 27th December, they're making this poor bastard's work over Christmas. Should have a holiday. Come on guys, let people have a Christmas holiday. The pictures I've seen of this do show it powered up and kind of working on one channel, the other channel not working. So we've got big traces coming down here, resistors in there, which is interesting. Big traces down to here, so these are obviously the main current path. Trying to see which terminal is actually going to, because we've got the binding posts attached to the front here. But at least it has part markings on it, which is always helpful. I haven't seen any test points as such. There's PCOM 1, which may be a test point. I don't know. Anyway. So we'll have a look over it. We'll power it up shortly and have a look and actually see if it works or not. There's these bloody horrible bloody caps in here. These tend to go bad. But that's what they are, you know. Nice solid clunking power switch. Always like a nice solid mechanical switch. Prefer that to soft power, really do. So it looks like there's some big MOSFETs and stuff down inside there, and the caps I can see down there look okay, there's no sign of bulging. I mean, these caps on here, these are Nichicon caps, so you know, they're likely to be Nichicon or something like that all the way through it. So obviously it's got GPIB built in, not like I use it, but it's got the functionality. Maybe one day I'll play around with it or something. I can see it's conformal coating everywhere, even though this metal chassis here has got conformal on it, sort of rusting. This is zinc plated, so that's fine. But that'd be zinc plated after it's been pressed. You can see it's got the scrape marks and it's still zinced, so that's been coated after it's been pressed. And that side chassis down there, that says 25th of October 2007 on that side plate just down there. Alright, so a month earlier than that, a couple of months earlier than that. And again, A shift, good old A shift. Okay, well, nothing obviously stands out as bad from just looking over it very briefly. Just a couple of big caps in there, Nichicon cap, massive one. Can't see values from here. Well, let's power it up and see what actually happens, shall we? Well, let's turn the Variac on. I'm running through Variac anyway. And power it up. Display looks good, nice and bright. Output turned off, turn the output on. Voltage settings. Sweet. Current, yeah, whatever. A voltage setting, 22 volts, it will limit that. Interesting. This is a 8 volt or 20 volt 1.5 amp supply, depending on how you have it set up. There you go. So that's channel 1 is 8 volt. Channel 2 is given this. Yeah, so this. So channel 2 is definitely 40, as explained in the listing. It's got unregulated specified there as well, so that's rather interesting. But channel 1's works, it means what it appears to. Let's chuck a multimeter on it and see what actually comes out of that. Right, so I've got my EV blog multimeter hooked up to it. Okay, so as you can see, output 1 is showing 8 volts like it should be as per the display, bang on 8 volts. Output 2 showing minus 0.27, pretty much as per the display. So what it's actually reading is what it's actually doing. That's kind of what I expected. So the output off, doesn't change. Check this one here, that's now off. Check that one again, that's still the same. So the output isn't switching, maybe a clue about what's going on. And these are independent outputs. I did a little play around with this just now and just actually like do that to it, for example, and just turn the output back on again. And I'm not getting any voltage there between that and that one, so the grounds are isolated from each other. So that's not a problem. Alright, so 0.27 there, stick that there, nothing. So yeah, so it's doing what it says it's doing on the front panel. It's a high voltage. Yeah, there we go. So that's the high voltage option there. So let's just try that and see what that does. Yep, 20 volts. Up at 2. Still minus. Yeah, no different there. So, okay. So it could be a bad MOSFET or something like that, which is just not outputting. It could be a short somewhere. Don't know yet. But it looks like a good little project to be playing with at some point. These are quite expensive supplies. I picked this one up quite cheaply because of being faulty, and I've actually got it even better than I expected. I did put in an offer which wasn't initially accepted. Well, there's actually no response to it, so I didn't say no either. But I was chucked in a bid towards the end and I got it. Nobody else bid on it, so I got this thing for a good price, even though it's only got one channel. You know, this channel here been not working. It's still a one channel Agilent linear power supply. Yeah, well, it's got a big bloody transformer, so of course it's linear. Right, so I'm playing around with this thing, trying to figure out where the fault is, and I've done lots of testing around various test points, and I've put together a big list of all the tests I've done. I'll actually probably link it in or put it in the description or something like that. I'll do something with it so you can see where the test points are, which I've checked and what values I've got, because that'll help you repair yours if you've got an issue with the voltages. Now, I've traced it down to two things. I've got two faults right now. When I first started out with this thing, when I turn the output on, channel 2 would say minus 0.27 volts. Now it says minus 5 volts. Right? And I don't know why that's changed. I think something else has blown whilst I've been doing testing. It doesn't change there either. Okay, if I change here, then it does actually. Right, channel 1 does work. So let's turn this on, and I'll show you on the meter. Channel 2 is still 0.27 volts, right, or minus 0.27 volts on the output, regardless of whether it's on or off. Makes a difference. That's still the same. But channel 2, as you can see, there, it's displaying 5 volts or minus 5 volts, regardless. Right. So I turn this up and down, nothing happens. But what I've discovered, if I get a load, in this case this thing here, let's hook onto these so I've got something to grab hold of, and I bridge this across. There's a little 5-volt regulator on here which also acts as a delay for the turn on the channel. It's U139. If I manually load up the output to a supply rail, so the input voltage regulator to the output voltage regulator, so I strap across there with a resistor, which is what's in here. I've got 5.6k, I think. Actually I did a smaller value than that. 4.7 seems more reliable. Now make sure the output's on. Yep, output's on. And if I bridge across there, it triggers that regulator to turn on, because that regulator's not turning on. And it's got a interesting setup on it. Here you go. Pin 1 and 2. The output is now on and working. How's that for interesting? Alright, now what there is, that's 0 volts up to 8 volts. Alright, so the output is now working. Now I just did that by bridging across pins 1 and 2 right there of U139. Okay, so pin 1 is the input, I believe, and pin 2 is the output, because the voltage on that pin is actually sitting around, I think it's about 2 volts, and it's got a feature inside it, so if it doesn't reach the set voltage, as in 5 volts, it doesn't reach it, it doesn't turn off the reset, because what it's got a reset pin that comes out, which then feeds to the gate of the output transistor, like the pass transistor, well, MOSFET, and the reset doesn't reset. It's actually pulling the line down, so it can't actually control itself. Right, it's like a power on safety feature. Right, so when it powers up, it doesn't have an output come on accidentally or something like that. Okay, it's a nice feature to have installed. You know, it means it can't power, you know, accidentally flick an output on when you first power it up. This chip here, this IC, which is supposed to be a voltage regulator, all they're using is the output reset. Right, it's got reset and a 5-volt regulator output. The reset is used only. The 5-volt regulator output isn't doing anything. It's just connected to a couple of components to make it be loaded slightly. Resistor and capacitor, right, for smoothing and loading. So that's all it's got on it. So the output isn't actually used, but the reset circuit is. But it's got an internal feature, so if the output voltage isn't reached, it doesn't clear the reset. The reset stays on, and that's what's happening. So that's why if I just touch the output to 5 volts and force at the trigger, it's okay. So either that part has failed, or an external part somewhere, there's a few parts here, is faulty. So that or the other. So anyway, that's what makes it work. But I still have this issue here, where it says minus 5 volts, regardless of what the output actually is. Right. So the output is changing, but now that's not, which is I've traced down to another fault. Down inside the guts of here, underneath that ribbon cable, there's, you can probably see one actually. It's on the point with. I'll point with this. Okay, so right there are some opto-couplers. Yeah. As you can see, one there. That's not the one I want. It's that one there underneath that ribbon, right there. That one there is the voltage sensing. It appears to be faulty, because if I measure the voltage across its input pins, I get 14 volts. which isn't correct, because it should be the LED voltage you get across there. Alright, it's not loaded, so I think the LED is actually blown. If I compare that to the other volts, I get 1.4 volts. So I should show you that, shouldn't I? Let's have a look, see if I can get in there and show you. It's a bit tricky to probe, which is why I've got these little needle probes. Very handy little things, these. Extremely sharp, you have to be careful what you do with them. So if I go into pin 1 and 2, there you go, 14 volts on those, across those two pins, which isn't correct. If I go to 1 and 2 of the next one over, 1.4 volts. Right? So that's what should be there. And the only thing that could cause that is the internal fault on that opto isolator. Now I do actually have some new ones. I bought a whole bunch of parts because I wasn't quite sure what I was going to need. Basically I bought everything I could see. Alright, I thought, well, I'm going to use them one day. Here we go, here's the optos. So I've got some in here. So these are HCNR 200-300. 300 means it's the surface mount version rather than through-hole version. But so yeah, I've got a whole stack of parts here. I've got opto-couplers and opto-isolators and op-amps. God. Output is off. If I turn the output on, channel 1, which it defaults to, you can see the channel 1. I've 1 up, that works, okay? And there's actually a voltage there. If I turn this meter on, hopefully you can see that over there. And if I plug the meters, I'll plug them both into this one for now. Plug them both in channel 1. Right, so I'm getting 6 volts channel 1. I'm getting 6 volts over here as well. Right, if I turn the load on, 1 amp, 1 amp. Right, so that's working just fine. Okay. Now, if I chuck it on channel 2, and I show you channel 2, right, it says minus 5 volts. Like I said before, when I first got it, it said minus 0.27, which was the actual output voltage. So it was originally reading correctly, but something's happened to it and it's failed whilst I've been diagnosing it. So that is output on, and you can see I've got minus 0.27 volts basically on the meter here. This doesn't say, it doesn't go below 0. And if I was to turn the load on, there is no loading, there's nothing happening here, right? There is just nothing, okay? So that demonstrates the fault in channel 2. I have to be careful because it's got mains voltage down one side, so I've got to be a bit careful about how I'm handling it. Now what I'm going to do is I'm going to show you what I do to make it come on. So you can see stuck tape over here to make sure I don't touch it accidentally, hopefully. Now over here is U139, it's actually marked on the bottom of the board as well. And it's, I say, 5 pins, so I'm going to touch pin 1 and 2 with a resistor. And you can see I've still got the output reading on there. It's currently, I don't know what it's set to. It's wind it all the way up. The display doesn't change, but the output does. The control output is still trying to change. So it's 4.7k resistor. That seems not a nice value to make this work. So if I probe between, touch those together. There we go. Takes a half a second or so, but there we go. 8 volts on the output. Okay, so it's forced the output to come on because it's caused that transistor to now turn on, or that IC to now turn on, and it's actually putting out 5 volts now constantly. It just needs a little bit of a help to get it going, and then it's okay, which is a little bit interesting. Although you still no voltage reading. Okay, it's putting out 8 volts, still nothing on display. If I turn on the load, 1 amp loading, 1 amp on display. So the current feedback is correct, right? So the only thing that's not working as far as readings is a channel 2 voltage, and obviously that MOSFET not being turned on. So that's the 2 faults it seems to have. Right? So it's a nice simple workaround to get that one working. If I just stuck a resistor across there, that would fix that, but it's obviously not the right way of doing it. Then I've got to fix this feedback. So that's the thing I'm going to try and fix today as well, and on the live stream, is to fix that feedback and see how we go from there, and try and replace those parts around that U139 and see if any of those things help, because it might not be U139, it might be something else around it. Now what I also did, if I get this, here's an LED, And if I stick this on somewhere, yeah, I'll stick on here, this might work. If I get these bloody cocktail clips are great, but the little plastic sleeves, they bloody slip around all the time, they're really slippery. It's really hard to actually squeeze them. Right. Stick those on there. So now this LED should light up when I put it across there. You think 14 volts, that's going to blow the crap out of the LED. Well no, because it's actually voltage. The voltage should be 1.4 volts. Okay, and it's a current limited system, so it's based on the current going into the optocoupler. So if the current is correct, the LED will light up nicely without blowing up. So can you see that there? Try and get it in shot at the same time. Alright, hopefully you can see it. So if I stick this across there, so on pin 1 there, pin 2 there, you see, lights up. Hopefully you can see it, I don't know. This doesn't light by very much, but that's lighting up. And now if you look at the meter, it's doing 2.2 volts. Right, so just the current of that LED brings the voltage down. Which makes me believe that that optocoupler has internally failed. Because as soon as you put an LED across it, the voltage drops down to where, close to where it should be. Right, obviously the LED type and stuff like that is going to affect it. But that's how I diagnose that input. Okay? So that's just a case of thinking about, hey, what's it doing? What is on the other end of those pins? Well, it's an LED. So, yeah, LED's got an open circuit, it seems. So the first thing I want to do is try and get that circuitry so the thing will at least turn on reliably. Okay, so that's the first thing I want to attack. Alright, like I said, this bit here, high voltage, when you got plugged in the mains, that bit right there has got mains voltage on it. So that's why I put the tape over it to try and stop myself from accidentally touching it. I'm aware it's there, which means you've got to be really careful with that sort of stuff, but being aware of it isn't necessarily the same as not touching it. Very easy to kill yourself doing this sort of stuff if you're not careful. So little things like that, it takes a little bit of effort, but it can potentially, you know, save a big bit of pain. So the part I've got to desolder is right there. It's those two pins there. Alright, so that is that capacitor, which I'm suspicious about, because that's the one that sets the delay time. I did actually measure it. Let's do it, measure it again. Although being in a circuit, it's not quite as reliable anyway. I'm going to leave that aside. That's correct. What do we get? So I'm getting 4.5 UF with 3.5 ohms, right? So it doesn't quite seem right, especially when it's supposed to be a 10 UF capacitor. Get plenty of solder on there. I might just pull the part out and suck the holes out. It might be easier actually. Let's just do it that way. Sometimes it's easier. Get my hand in there. Okay, parts out. Now I'll suck the holes out. Parts in there somewhere. Here we go, it's out. Okay, hole's cleared out. Now let's find that part. It's on my desk somewhere. It did fall out. So that's actually a 4.7. Interesting. That is not what's on the diagram. Right, so that's a 4.7 50 volt. But the diagram had a 10 UF on there. Very interesting. I found a lot of discrepancies in the diagram. As did Jerry Sweeney when he was doing his video. So there's various things there which just don't match up. So we'll put a new 4.7 in. What voltage is this one? Another 50 volts, so it's basically the same. So the Nikon cap. Nice good quality cap. So I can get my hand in there to put it in. I might take this board out actually, let's do that. So I'm just guessing this may or may not affect anything, but obviously the capacitance reading was ended up being correct in the end because it had the wrong capacitor in there, well, a different capacitor in there. Solder this in, then we'll give it a try and see if it actually changed anything or not. We'll try and get the heat right through the board because it's double-sided. Right, fingers crossed this does something. I'll be surprised if it does. I think the IC is probably bad, but I'd rather try and do these simple fixes first. You never know, might get lucky. Let's put one screw back in this so it doesn't flutter around. I think that's why it's hard to get the circuit diagrams for them, because of the current module. It seems that Keysight, as they are now, you know, formerly HP and formerly Agilent, I think if it's obsolete equipment, then they release the service information. If it's something that's no longer supported properly, or no longer current model, I think then they actually allow the service information out, like the diagram, stuff like that. So you can get a lot of the older gear, you know, diagrams not a problem. But because this is a current model, their service information you download from the site gives you a board layout, excludes circuit diagrams. So there was one guy at one place which had the circuit diagrams included. So I think there's like only one copy in existence where you can get the diagrams. So I'll be uploading that to my site to share that too, so other people can see them too. Obviously the voltage isn't going to read correctly. It's still been reading -2.7. So yeah, that's still dead. So that hasn't fixed that. So it must be the IC itself which is bad, so I can't fix that right now by the looks of it. Which is a shame. I was hoping I could resolve that one today. Obviously the IC is bad. Must be. Yeah, it happens. But that's okay. So the next thing I want to look at then is that opto-coupler. Right, so now we've got to get into here. Now I should be using this, but I rarely do, unless I'm really worried about blowing up. Now let's just take this. Let's take this board right out. I think we'll see if I can get to it or not. Because the optocoupler is right down there. I need to try and get that out. So let's just so I'm not messing around with this board trying to work around it. Let's just take the board out. Is that unplugs? Look at this. Yes it is. Come on, let's come. Okay, let's get out of the way. Okay. Yes, that's the key plug, so I can't get that wrong. Let's pop this out. Come on. Okay. So, hope you can see that okay. Alright, but the optocoupler I want is right there, that one there. So it's a bit tricky to get to. I've got two choices how I can get this out. I can try and do it non-destructively, or I can do it destructively. I'm going to need a bit of room because it's a bit tricky. Now, as I was saying, I can either do it destructively or non-destructively, which is where I cut the legs off the IC and then take the legs off one at a time. Or I could try using hot air and try and get it out without disturbing anything around it. I think I'm going to cut the legs off because I've got new ICs. I believe that IC is bad anyway, so I've got nothing to lose. So new ICs, if I can find them. So I find I've lost them. There you go. New ICs are here. Alright. So I've got one right there. Should double check it to make sure it's all good. Okay, so yep. It's got the right parts, part number on it at least, so that's the part there. So that's what needs to go in. So it looks correct. So I think I'm going to cut the legs off and then take the legs off one at a time, put the new piece in after clean the pads up, and we'll give it a go. If I at least get the voltage reading correct, then I've only got to worry about then that reset circuit and get that going. Now let's try and snip these off. There's still a risk of damaging pads doing this, but you just try and be careful with it. You just don't force too much. Come on, off you can. If I get onto the pen, it'd be great. Right. Whole part out. Okay, that's probably the most general way I can do it. And it is rather sensitive electronics around here, so if I stuck a lot of hot air in there, I could disturb other parts or who knows what else. So I'm a bit reluctant to do that unless I really need to. Come on. Okay, so legs off. Let's get some fresh solder on these pads. It's probably lead free or something, I don't like lead free. But it melted quite easily, so maybe it's not. Now, I know a lot of people use solder wick, whereas I don't tend to. I probably should, but I've never had much success with it. I've always found it awkward to use. Anyway, we'll give it a go with this. There you go, nice and clean. I'll clean the flux up afterwards. Yeah, it's satisfying repairing things. I always like to bring things back. I mean, I get a lot of satisfaction for getting something which is broken and then bringing it back to life and making it usable again. I don't like to see waste. It's like one of my little hates. I don't like seeing wasted things, you know. Things which could be fixed or are still usable. I don't like to see it just, you know, thrown away, destroyed, pulled out for parts even, you know. Something which could be fixable. It just, I hate it, you know. I see this, if you look on eBay, you see these various cards, you know, you might see, you know, all the cards from a piece of test gear and think, well, why don't let's put the cards back into the piece of test gear and sell it as a broken unit and let someone try and fix it, you know. Because you think, well, yeah, but what happened to the rest of the unit when they've broken the cards out? And then the chassis has been destroyed, you know. That's a waste. Someone might want the chassis. I hate seeing waste. It's one of my little pet hates, you know. I really don't like to see waste. You know, I really like to try and bring things back and, you know, restore things like that. I don't like to see things going to waste like that. Even you've probably seen some of my Mailbag videos where I've got lots of packaging on things. All that wasted packaging, all that cost and expense and all that, and just the volume of waste generated just to send 5 transistors or something, you know, a massive package of bundle like this for little 5 transistors. It's like, come on, you know, that's what's wrong with the world. Anyway, it's my pet hates. Right, so let's get this thing soldered in. I think that looks okay. I love restoring bits of gear like this. The hard bit is trying to find the gear, because I find that prices going up on eBay. Right, mainly the postage prices are becoming prohibitive. You know, I could buy a piece of gear for $50, but the postage is $300. You know, stuff like that. It's just ridiculous. And you know, it's just not worth it. So I'm having more and more trouble now finding parts. You know, well, finding gear to work on, because the postage is just ridiculous. You know, I'm looking, but trying to find something suitable to work on, not always easy. What iron am I using? I've done a few videos on this actually. Now this is a fake Heiko, right? It's an FX951, a Chinese one. I did a Mailbag video on it. I did a video on tearing it down, having a look, and I've done a couple of videos on the handpiece. Now this is a replacement handpiece. It's the second replacement handpiece I've used. I got this one off eBay. I think you can get them on Banggood and stuff like that as well now. But it's a nice metal one. And this is by far the best handpiece. So I'm still using the cheap Chinese fake Heiko, right? Which works fine. But you need to replace the handpiece with a good one, right? Get a good handpiece, it makes it usable. Without replacing the handpiece, it's actually absolute crap. It really is crap. You know, so it's one of these things. Let's shove some flux in there. It's going to need some help. In fact, I think all the pins probably use a bit of flux actually. I might just chuck a bit in all of them. We did them all. Not perfect. This transistor here, which is bent over slightly, it's kind of in the way. Come on. Here we go. Now it's soldered. Probably should put flux on in the first place, but this stuff's got quite a good flux in it. It works really well, so I don't usually need to add flux unless it's been problematic like that last one was. Cool. Well, good. Let's have a little bit of a look, make sure there's no bridges. I've got a bit too much solder on that leg there. When it did finally flow on, it flowed on too much. Yeah, I'm being fussy. Slightly better. It's okay, it doesn't really matter much. It just looks a bit funny. Right, let's clean this up. I often get asked, almost every video I do cleaning, what are you using? Just IPA. Just a bit of IPA, that's all it is. Then I get asked about what these are. These are makeup cleaning pads, right? Makeup remover pads, because they're really cheap. You can get, you know, loads of them for a couple of dollars, and they're lint free. And they're really good for this. You can just shove it in there, and it absorbs all the flux, and it sticks to it. It's great. This is a bit hard to get into with, but right. This isn't going to be very effective for cleaning, I'm afraid. Might have to flush it out rather than this, but anyway. Just a bit hard to get to. I'll do it this way. So we'll find out shortly whether or not this solves the voltage reading issue. Really hope so, because this is what I thought it was. Okay. Yeah, it looks alright. Cool. That looks fine. Certainly good enough. Now I need to plug these things back in where they were. Plugs in there. Plug that in afterwards. I need to get the ribbon. I mean, really I should have taken the board out to work on it because it's working a bit better, but I could just get it without taking the board out. It's a lot of hassle to strip this thing down. So I just wanted to avoid going there if I could. I'll figure out this layer here that goes like that, goes like that. Okay. Let's get the board back in. Whenever I touch things, I'm always touching the metal first, or the metal parts first. I always make sure I touch the ground plane first, because that way much less likely to blow something up. using static, right? Because I don't have this strap on, right? So, but obviously the bench is grounded. So it's just the thing I always do. I always touch metal things first. Always. It's just, it comes second nature. I don't think about it anymore. I just do it. I never blow anything up with static anyway. At least not to my knowledge. So I think my precautions are adequate. If I'm working on something that's particularly sensitive, then maybe I'll worry about using a strap, you know, that's what I've got the thing here for. Or even like something that's not mine. I should rephrase that. I should put on the anti-static strap. That could be misconstrued. Right, shove that back in there. One more wire to attach after that. Then we'll pair it up and see if it's any different. Okay. That's a relief. That's working okay. Channel 2 is back to reading 0 volts again. Great. So something. That's a relief. So that's back to where it was. So that looks like it's working again now. So let's do that thing with the IC and force it to come on and see if we actually get an output voltage showing up on display. Okay. So it's now showing 0 volts, and you can't see that one. There we go. Turn it on. Hey, look at that. Works. Yep, works. So I've solved the display issue, right? So that opto-coupler was definitely a problem at display. So cool, that works. Anyway. So yeah, that works. So I've just got to sort out that reset IC. This part's interesting, but it's jumping around like that. Right, I know, that's working. Cool, so that's one of the faults at least fixed. Let's double check this channel, make sure I'm happy with that. 8 volts, yeah, it's all good. So there's still something a little bit funny going on at channel 2, I think. Because see, this one stays rock solid when I'm changing voltage. Right, that's alright. But the channel 2 is behaving a little differently. So maybe still something a little bit subtle there. Change that to a quick channel. Something's still not quite right there. So each step I'm going up, it's changing by less than 1 volt. Maybe it's a calibration thing. Yeah, probably a calibration issue actually. Because this is reading back the actual voltage. So it probably is a calibration thing. Yeah, cool. So that's partially fixed at least.